Hi, welcome back to the final part of our trigonometry and calculus exam series. In this video, we are going to focus on trigonometric identities and angle formulas. So this covers question 2b and question 3a of our exam question series. But before we begin solving today's questions, let's quickly go over some very important trigonometric identities and angle formulas that are going to be very useful to you, not only for this video, but for so many exam problems that you'll be facing in future. Now let's find the exact value of sine 75 using the sum of angles formula. Now we can easily recall that sine A plus B is equal to sine A cos B plus cos A sine B. So following this pattern, we can now decide to split 75 degrees into two special angles. So that makes it easier for us to have an expansion of something like this. So we can now have sine 75 will give us sine 45 degrees plus 30 degrees. So what we have here is still exactly the same thing as this. So with this, we can now follow this same pattern of expansion. So what we now have is sine 45 degrees cos 30 plus cos 45 degrees sine 30 degrees. So we are now going to replace these trig functions. We are now going to write them in form of ratios. So don't forget that sine 45 is 1 over root 2, cos 30 is root 3 over 2, cos 45 is 1 over root 2, and sine 30 is 1 over 2. So let's actually follow those pattern and put on the ratios there. We have 1 over root 2 multiplied by root 3 over 2 plus 1 over root 2 multiplied by 1 over 2. So we can separate that with brackets. So what we have here is using the numerator to multiply the numerator will give us root 3. So we do the same thing for the denominators. Root 2 multiplied by 2 will give us 2 root 2 plus, we do exactly the same thing to this side. So we have 1 over 2 all over root 2. So here we can have our denominator to be 2 root 2, so that we now have root 3 plus 1. So this is just a simple way of taking LCM of 2 root 2. So you simplify in a very simple way. So we have root 3 here plus we have 1 here. Now we cannot leave our answer like this. We have to rationalize the denominator. We do not want to see this irrational number here. So we have to rationalize this denominator. And for us to do that, what we just have is that we have root 3 plus 1 over 2 root 2 multiplied by root 2 all over root 2. So using the numerator for the numerator, so what we have is root 2 into brackets root 3 plus 1. That is using root 2 to multiply this expression to give us this, divided by using 2 root 2 to multiply root 2. Root 2 and root 2 will give you 2. So that 2 multiplied by 2. So that is having something like this is 2 here. Then multiplied by root 2 and root 2 will give us 2. Something like this. So eventually, when you expand that bracket, root 2 multiplied by root 3 will give us root 6 plus root 2 multiplied by 1 will give us root 2 divided by 4, and that becomes our final answer. So as long as you don't have a square root in your denominator, that simply means that your answer has been simplified. That is how simple it is. Now let's prove the double angle formula for question 3a, which happens to be the final question for our series. Now, making use of the sum of angle formula again, you can recall that sine A plus B is equal to sine A cos B plus cos A sine B. Now, if we are to follow the same pattern of this expansion, then you will agree with me that 2a is also the same thing as a plus a. So we can now say that sine 2a is equal to sine a plus a. So we can follow the exact pattern of what we used here to expand this one as well. The only difference is that in this case, we are not making use of b. So we are using a and a. So what we now have is sine a cos a plus cos a sine a. So if you look at what we have here and what we have here, you will observe that they are both the same thing. Forget about the fact that cos a is creating force a. So cos a sine a is exactly the same thing as sine a cos a, because we are multiplying the two together. So therefore, we can now conclude that this is the same thing as 2 sine a cos a. So we can see how simple this is, and that wraps up our series on this essential trigonometry and calculus exam questions. We have covered differentiation techniques as well as key identities and angle formulas. Thanks for watching. If you find this series very helpful, don't forget to like, share, and subscribe for more clear exam-focused math videos. See you in the next video. Thanks and God bless you.